Assalamualaikum and hi everyone. My name is Madam Noon. See you again. In this video, we will discuss the objective question that relate to the topic 8, which is about the physical optic. There are 28 objective questions that we will discuss. So take a look at the questions. The first question, which of the following statement describe about the Huygen principle? So actually Huygen principle is related to the point to the wavefront that where each point on the wavefront acting as a point source and produce a secondary wavelet, and the envelope of this wavelet will produce the secondary wavefront. So the best answer for question number 1 is D. For question number 2, Huygen principle of light considered light to be. So if we look at the explanation here, Huygen's wave theory of light considered light to be a periodic disturbance that is transmitted through a medium in the form of longitudinal wave. So this theory explained about the reflection, refraction, diffraction, and also the interference. So the best answer for question number 2 is C, which is longitudinal wave. For question number 3, which among the following is an example of coherent source? So if you refer to the choices given, A is laser, B is LED light, C is fluorescent tube, and D is tungsten filament lamp. So the best answer is A, which is the laser. For question number 4, identify the factor that is not the same for coherent wave. So the factor that not same for two coherent wave is the amplitude. The rest is supposed to be same. Question number 5, which of the following is a form of light that share the same frequency and their wavelength are in phase with one another? So this is about the definition of the coherent sources. So the best answer is B. For question number 6, the shape of the interference pattern observed depends on. So it depends on shape of the slit. Okay, so the best answer is A. For question number 7, figure shows the interference of two coherent sources. Which of the following statement is true about the above figure? So the best answer is all of above, because of if you refer to the S1 and S2, both is the coherent source which is antiphase. Okay, and then at the point P, the cancellation of the amplitude occur, so dark fringe will produce, and the path difference for the antiphase for the destructive interference is equal to m lambda. That's why the answer is D. For question number 8, what happened to the interference pattern if the phase difference between the two sources varies continuously? So the answer is disappear, because of referring to the explanation for the bright and dark fringe which is changed rapidly, we cannot see the change by our eyes. Because of that, no, we cannot see any interference pattern on the screen. Okay, and for question number 9, identify the condition which is not necessary for two light waves to be coherent. So referring to the choices given, the best answer is B, because of the two light source should be narrow. Actually, narrow is referred to the size of the slit. For question number 10, the main principle used in interference is, the answer is superposition principle. For question number 11, when two waves of same amplitude add constructively, the amplitude of the resultant wave becomes, of course, because of this is constructive, so the amplitude will be double. For question number 12, bright spots on the interference pattern are visible because of, meaning that we can see the bright spot. This is because of the constructive interference, because we can see. And then for question number 13, if the separation between the two slits is decreased in the Young double slit experiment, keeping the screen position fixed, what will happen to the width of the fringe? So for this case, we refer to the equation for the separation distance, which is equal to lambda d over d. If the separation between the two slits, which is small d, is decreased, so the separation distance will be increased, meaning that the width of the fringe will increase. For question number 14, in young double slit experiment with monochromatic light, how is fringe width affected if the screen is moved closer to the slit? So we refer to the explanation here, which is the separation distance is equal to lambda d over d, and if the distance between the slit and the screen is decreased or move closer, the separation will also decrease. That's why the answer is B. For question number 15, in young double slit experiment, if the distance between the two slits is half and the distance between the slit and the screen is double, then what will be the effect on the fringe width? Okay, for this case, we refer to the equation of delta separation distance. We just substitute the half d and also the 2d. Then we calculate, we will get that what happened or what will effect on the fringe width. The fringe width will increase 4 times. For question number 16, figure shows the light wave reflected from the upper and lower surface of a soap bubble. So both ray 1 and ray 2, if you look at the ray 1 and ray 1 is reflected at the upper surface or on the denser medium, so undergoes the pi radian phase change, and ray 2 is reflected on the less dense medium, so undergoes 0 phase change. Because of that, the phase difference is equal to pi minus 0 is equal to pi radian. If pi radian, the two coherent source is antiphase. So the best answer is A. For question number 17, when a wave undergoes reflection at the denser medium, what will be the phase change? So for the ray which is reflected on the denser medium, they will undergo pi radian phase change. For question number 18, which of the following does not show any interference pattern? So the best answer is C, which is excessively thin film, because of too thin we cannot produce the interference pattern. For question number 19, a small circular disc is placed in the path of light from a distant source. Identify the nature of the central fringe produced. So to answer this question, take a look at the explanation. Waves from the distant source are diffracted by the edge of the disc. This diffracted wave interfere constructively at the center of the shadow and produce a bright fringe. Therefore, the nature of the fringe produced is bright. For question number 20, single slit diffraction is completely immersed in water without changing any other parameter. How is the width of the central maximum affected? We refer to the explanation where wave of light in the water will decrease, wavelength of the light in the water decrease. So the width of the central maximum also decreases. That's why the answer is B. For question number 21, which statement is correct about the young double slit interference pattern and single slit diffraction pattern? So if you look at the choice A, the width of the central fringe is different in size. Yes, it is correct. The central for both pattern is bright fringe, also correct. And C, pattern consists of alternating dark and bright fringe, also correct. So the best answer is all of above. For question number 22, what principle is responsible for light spreading as it passes through a narrow slit? So the answer is diffraction. For question number 23, which of the following accurate define diffraction? So the best definition of diffraction is the spreading out of the wave around an obstacle or the spreading out of wave as it goes through a slit. For question number 24, what is the cause of diffraction? So, referring to the explanation, the diffraction occurs due to the interference of secondary wavelet. So, the answer is D. State the essential condition for diffraction of light to occur. So, the size of the aperture slit must be less when compared to the wavelength of light. Question number 26. When does single slit diffraction occur? So, single slit diffraction occur when the slit width is smaller than the wavelength. For question number 27, when a monochromatic light incidents on the diffraction grating, the diffraction pattern of order n is equal to 4 is observed on the screen. How many maximum or bright fringe form on the screen? So the answer is 9. How we get this answer? From the calculation, if the order is equal to 4, the number of fringes is equal to 4 times 2 plus with 1 for the central bright, so it is equal to 9 bright fringes. For question number 28, if instead of monochromatic light, white light is fall on the grating, what would be the change in the observation? So, if the white light is fall on the grating, we will observe the rainbow colors, and at the central is still white bright fringe produced. So, that's all for the discussion of the objective question from topic 8, which is about the physical optic. So, how's everyone? Is it okay? So, thank you very much for watching, and I hope that you do take care of yourself and stay safe always. I wish you all the best and good luck for your UPS. If you think that this video helped you to understand the about topic physical optic, can you please click the subscribe button, like, and please share this video with all of your friends. If you leave a comment, I really appreciate that so that I can improve my next video. So thank you very much everyone. See you in my next video.